Hey guys, it's Meredith. I just wanted to talk to y'all about a couple questions you had in class. One about the West zones and how to change them, and then I just also wanted to add a little bit about shunting. All right, so just to review the West zones, here's a picture of some lungs. There's your airway. You have your pulmonary artery coming out here. And remember, because of gravity, you're going to have a little bit of blood up, normal blood out to the side there, and then most of the blood is going to be all at the bottom. Then remember, the air is actually the least at the bottom, middle in the middle, and then the most at the top because air rises. And so then remember, we made sort of three areas, 1, 2, and 3, and those are called the West zones. So y'all's question was, how does hypoxic vasoconstriction make zone 3 smaller, zone 2 bigger, and also zone 1 smaller? So let's imagine a balloon and say that it's a water balloon, but it's not filled up all the way. You know the bottom of the balloon, because of gravity, has the most pressure of water. Say you squeeze that's hypoxic vasoconstriction. Then the column of water is going to rise, thus increasing the pressure toward the top of the balloon. Now, you decreased your zone 3 by squeezing, and then your zone 1 actually is going to get smaller too, because the water is going to rise up into it, making it more like zone 2. But will there still be VQ mismatch because zone 1 has so much air? So let's remember the relationship between the alveolus and the capillary bed. Zone 1 has a big alveolus, small capillary. Zone 2 is more equal, and zone 3 has a small squished alveolus with a large engorged capillary. So then what does squeezing the balloon, or hypoxic vasoconstriction, do to each of these zones? So it's obvious that first, it decreases the size of the capillary adjacent to the zone 3 alveolus. And remember, because of that, the pressure is going to go up and it's going to fill more vessels in the zone 1. Now it's time to remember thinking about the alveolar capillary relationship like that balloon with the fishnet stocking around it, such that since we're increasing the amount of blood in the capillaries in the zone 1 area, the alveolus is actually going to also get smaller. Thus, the vessel's getting bigger, the alveolus is getting smaller, and they're closer to matching, just like a zone 2 alveolar capillary relationship. The same but opposite happens in zone 3. Since you squished up your vessel, now the alveolus there can expand a little bit. So now both zone 1 and zone 3 are more like zone 2, thus the zone 2 increases. Lastly, I just wanted to give you guys a couple other examples of shunts that we see in the hospital. Remember, we talked about pus filling the alveolus being a shunt because as the blood flows past, there's no gas to pick up. So it's basically a fluid passing a tissue, and that's what's known as a shunt. This can happen on a larger scale too. So remember, left heart sends blood to the body, body takes oxygen out, deoxygenated blood returns to right heart. Right heart goes and gives that blood to the lungs, which give the blood oxygen and return it to the left heart. If someone has a hole in their heart, where the right side of the heart is connected to the left side of the heart, this is another type of shunt. As you can see that the right side is going to the left, completely bypassing the tissue that is the lungs. This is known as an intracardiac shunt and is most often caused congenitally. You can also have this problem on a smaller scale. So here's a picture of a normal alveolus, and here's the capillary bed that's passing it by. Remember, the pulmonary artery in blue brings deoxygenated blood from the right side, and it passes through this capillary bed, picks up oxygen here, and then it goes to the pulmonary veins demarcated here in red. However, if the pulmonary artery has a direct connection to the pulmonary vein, i.e. bypassing the capillary bed, then you're completely shunting blood past the tissue that is the alveolus, and this is called an arteriovenous malformation and is another example of a shunt. Thank you guys for listening. I hope this helped answer a couple questions and give you a couple more examples of shunting. Please feel free to email me if you have any further questions, and we'll see you next week to finish off our lectures for the module. Thanks.